All right, guys, so let's continue to talk about lesson 9.6. In my last video, I called it lesson 9.7, and that's not true. This is lesson 9.6, and this is the final lesson that we'll work on this year in your Algebra 1 class. And we've just gone through the fact that the quadratic formula will help you find the solutions to any quadratic, regardless of whether or not the roots are complex roots, or they are non-integral roots, or if they are integers themselves. The quadratic formula is going to help you get there. It's important for you to recognize that you need to have your quadratic formula written in standard form so that you can identify A and B and C. There's a little bit more that I want to talk about before we actually work through an example, and that's the idea of the discriminant. You're going to be thinking about that or being asked questions about the discriminant. And the discriminant is simply the part that's under the radical. So under the radical, b squared minus 4ac, this is the part that we're talking about. This part right here is what we call the discriminant. And it helps you to determine, it helps you discriminate, it helps you determine the number of roots that you're going to encounter when you finish solving that. And so here is the case. If the discriminant is positive, well, that's going to lead to two roots. And when you think about that, if you go back up to the idea that it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, what we're saying here is if this amount underneath the radical is a positive amount, well, then it would stand to reason that you're going to end up with two roots, because you're going to have some amount, this negative b, and you're going to add the square root of that positive value and divide it by 2a. That will give you one of the roots. And then you're going to do it again. You're going to take this negative b, and you're going to subtract the square root of whatever this positive value is and divide it by 2a. And that's going to be your second root. So you're going to be asked to determine how many roots there are just by looking at the discriminant. You don't have to go through the whole quadratic formula. Well, let's think about that. It's possible that you could do b squared minus 4ac, and you could end up with a discriminant that is 0. So if you do b squared minus 4ac and you simplify it and you end up with 0, well, that's going to tell you that you're going to have just one root. That's a quadratic that's either sitting on the x-axis or hanging down from the x-axis. And think about that. That means we're going to have negative b plus or minus the square root of 0 divided by 2a. Well, the square root of 0 is just 0, so all we're going to end up with is whatever negative b is over 2a, and that's that one root we're talking about. So the discriminant, let's just recap. The discriminant could be positive, and that will give you two roots. The discriminant can be 0, and that will give you one root. But it's also possible that the discriminant could be negative, right? This b squared minus 4ac could equal a negative number. Well, and what is that going to tell us? Well, you cannot take the square root of a negative number. Remember, that's imaginary. So if you evaluate your discriminant and you come up with a negative number, what that tells you is that there are no real roots. There are no real roots. That's an example of a parabola that never crosses the x-axis. Maybe it's above the x-axis and has a positive leading coefficient, or maybe it's below with a negative. Regardless, what you're going to do when you come up with a negative discriminant, this guy right here, negative discriminant, is you're simply just going to say, well, that's easy enough. There are no real roots.